To check for live systems, there's a lot of different things you can do. One of the most common way to check for live systems is by doing a simple ICMP scan. Now, in this type of scan, basically what you're going to do is you're going to ping each one. You're going to send out an ICMP packet, and hopefully you'll get a response. Now, this can be very effective because you can run these in parallel so that it runs very, very fast. And if you are having problems with the network, or if just the network's maybe a little bit slow, you can also tweak the timeout by setting the -T option on your ping itself. One of the tools you can use for this kind of a scan is called Angry IP, and it is an IP scanner that's basically for Windows. It can scan for IPs in any range that you give it, and it simply checks each IP address to see whether or not it gets a response. And it can also give you NetBIOS information such as what's the computer name, what's the work group name, and the MAC or address as well. Another tool you can use is hping2. Now hping2 is a command line TCP/IP packet analyzer / assembler. Not only does it do ICMP requests, it also does TCP, UDP, and raw IP protocols. It has a trace route mode, and it does have the ability to send files between a covered channel. Now, the features of this product are that you can use it to test what kind of firewall, and indeed if there is a firewall there. You can do advanced port scanning with it, network testing such as fingerprinting of your different OSs. You can use the advanced trace route, which is supported underneath all protocols. This does let you also check the uptime of the system, as well as doing audits on the TCP/IP stacks themselves. Another good tool is a ping suite. Now, this is also sometimes called an ICMP suite, but basically what this does is it scans a whole range of IP addresses to find the live ones, in other words, the ones that are going to respond. A ping suite basically consists of echo requests that are sent out to multiple hosts. If I get a return, then I know I've got a live one out there. If I don't get a return, doesn't necessarily mean it's not there, but it means that that may not be there. Another tool is Firewalk. Now, Firewalk is intended to be a network auditing tool. What it does is it tries to determine what type of protocols a given gateway will let through. Now, the Firewalk scans work by sending out TCP or UDP packets with an IP time to live, which is 1 greater than the targeted gateway. That way, I can go ahead and try to get through the internet or get through the filter to get a response from it. Now, once we know which ones are live, then we're going to check for open ports. And by far the most common tool that we use for this is called Nmap. Now, Nmap is free, it's an open source utility, and basically it's for network mapping. That's the name, Nmap. It's designed to rapidly scan your networks and find out different information. It has a lot of different features. It can do port scanning, OS detection, version detection, ping sweeps, a lot of other techniques as well. It can also scan a large number of machines at the same time, and it is supported by multiple operating systems. So it's not just a Windows-based tool. In fact, it's more commonly used on the Linux or even a Unix environment. So it can carry out all kinds of different pings for you. Some of the different scan methods that you can use with a product like Nmap would be a Christmas tree attack. And this is basically when you send a Christmas tree type IP packet. There's also the send stealth. This is referred to as kind of a half-open scanning. In other words, you really don't create a full TCP connection. You just create half of a connection. There's also null scans. And this is basically an advanced scan that sometimes can pass through certain firewalls. There's also a Windows scan, which is similar to an ACK scan that we can use to detect open ports. And of course, there is the ACK scan itself, which we can use to map out firewall rule sets based upon what kind of responses we get. Now, a send stealth, or a half-open scan, is often referred to as half-open because it doesn't open a full TCP connection. First, a send packet is sent to a port of the machine. And what that does is basically say, hey, I want a request for a connection on that machine. And then I wait for a response. If the port sends back a send ACK packet, then I can infer that there is something that's listening on that particular port. If a reset is received back, then the port is not active or not listening. So as soon as the send ACK packet is received, then I send back a reset. So in other words, I don't complete the connection. This way, I don't open it all the way and I can't be detected as easily. The key advantage to this type of scan is that fewer sites are going to log a half connection. A lot of sites will log a full connection, but they won't log a half connection. Now, speaking of the different kinds of packets or the different kinds of flags that you can send on a TCP packet, let's take a look at what some of them are. You have the synchronize, or also known as the SYN, and this is basically used to start a communication between two hosts. Next, you have the acknowledgement, or the ACK flag, and this is also used in establishing a connection between the two hosts. Next, I have a push, and this basically instructs the listening system to send me everything you have in the buffer right away. I also have an urgent, which states that the data in the packet should be processed immediately. Next, I have a fin, or a finish, and this tells the remote system that I'm not going to send any more transmissions. And finally, I have the reset, and this is basically used when I want to reset a connection. So, the way this works is, if you're doing a typical TCP connection, what happens is that computer A would send a SYN packet over to computer B. Computer B, if it's listening on that port, would respond with a SYN and / acknowledge packet. Once that's received, in order to establish the connection, then computer A would send back an acknowledge packet, or an ACK. At this point, our TCP connection is opened with this other computer. So with the stealth scan, what we're doing on the stealth scan is we send the SYN from computer A to computer B. Now computer B, or our target, responds with a SYN and an ACK, only instead of sending back the normal ACK, you send back a reset. And what this does is it destroys the connection, but at least I know that somebody's listening there. Now with a Christmas tree scan, I'll get two different responses depending upon what I'm going to get. For instance, computer A will send a finish, an urgent, and a push packet, with one packet with all three flags set to computer B. If computer B does not send a response, in other words, I don't get anything, then I can assume that that port is open. However, if I get back a reset or with an acknowledge flag, then that tells me that that particular port is closed. Now, this is only going to work on OSs that have a TCP IP implementation that goes along with RFC 793. Now, the Xmas scan or Christmas scan will also not work against any version of Microsoft Windows. And if we direct it at anything that is running a Microsoft operating system, basically it's going to show all the ports as being closed. A fin scan is another type of scan. In this case, computer A would send back a fin packet to computer B. If computer B does not respond, in other words, I get nothing back from it, then I know that that port is open. However, if I get back a reset / ACK packet, then I'll know that that port is particularly closed. Again, now your OS has to conform to RFC 793. And again, Microsoft Windows operating systems will not accept a fin scan. So if you try to send one, it will show all the ports as being closed. Another type of scan would be a null scan. This is basically where I just send a TCP IP packet from computer A to computer B, only this time I don't set any flags. Again, if I do not receive a response, then I know that that port is open. However, if I receive a packet back with the reset ACK flag set, then I know that it is closed. Again, the OS has to comply with RFC 793, and again, it will not work on Microsoft Windows operating systems.